Hi, today we are going to learn about derivation for the equation of molecules which are dissociating in case of distribution coefficient. In case of distribution coefficient, if the molecule is dissociating, what is the equation? If the molecule is dissociating into two, the equation will be Kd is equal to C1 by C2 square. So, how to derive this equation? We will try to see. So, assume that we have a organic and aqueous layer here. So, when you add a molecule to this layer, what happens? This HA molecule will first partitionate between organic and aqueous layer. This is organic layer, this is aqueous layer. It will partitionate between organic and aqueous layer. So, when it comes to the aqueous layer, this HA molecule will react with water molecule and form H3O plus and A minus. Okay, so it is dissociating into two molecules. So, in this case, how to derive the equation? So, we will try to write the equation for this one. So, according to the distribution coefficient, what is the equation? C1 by C2. What is C1? Concentration of your HA in organic layer divided by concentration of HA in aqueous layer. Concentration of HA in organic layer is your C1, we already know. But in case of C2, the molecule is dissociating. So, we need to find out the value of concentration of HA in aqueous layer. This value we need to find out. So, for aqueous layer, what is the concentration of HA, and substitute that value here, you will get the equation for this. Okay, we will try to see this. So, your molecule, when it is entering into the aqueous layer, it is reacting with water and it is forming H3O plus and A minus. That was the equation for this. Now, apply law of mass action. Constant is equal to concentration of H3O plus multiplied by concentration of A minus divided by concentration of HA. In this case, we neglect the concentration of water because water is present in the plenty. We assume that the consumed water is very less. So, we take concentration of water as constant. So, we do not take the concentration of water in case of denominator. So, next equation is, see here, if one molecule of HA is dissociating, it is dissociating into one molecule of H3O plus and one molecule of A minus. So, the concentration of H3O plus and A minus are same. In that case, I will take H3O plus square. Why I am taking square? Because concentration of H3O plus and A are same. You can take A square or H3O plus square. I am taking it as, for convenience, as H3O plus square. So, divided by HA concentration. This will be your concentration in what? Aqueous layer. That what it is. So, this will be the aqueous layer. We are adding that into the aqueous. After going to the aqueous layer, it is dissociating. So, solve the equation for HA aqueous. So, HA concentration in aqueous layer is equal to H3O plus square divided by, what is it, divided by constant K. So, assume this equation as 2 and assume this equation as 1. So, substitute 2 in 1. This equation has to be substituted in this equation. So, how it will come? So, Kd is equal to HA concentration in organic layer divided by HA concentration is aqueous layer. So, instead of that, we write H3O plus square divided by K. Okay. So, if you rearrange this equation, you get Kd is equal to HA organic into K divided by H3O plus square. So, take the constant at one place. So, we get Kd by K is equal to organic layer concentration is C1, aqueous layer concentration is C2. Because we have square, we will write square here. Then concentration by concentration is constant by constant is constant. We will write it as a constant, which is equal to C1 by C2 square. So, this is the equation for molecule which is dissociated into two molecules, we'll put square here. So I hope you understand. Thank you.